Hi guys, today we're going to be talking about trig functions through a specific point. One thing to note first is that if we are ever evaluating trig functions of uncommon angles, which are angles that do not reference 30 degrees, 45 degrees, or 60 degrees and are not quadrantal, which we'll talk about in a little bit, we will use the calculator. It is very, very important that you round your answers to 4 decimal places if necessary to be as exact as possible. And then biggest note here, make sure the mode setting is set to the correct form of the angle. If you guys are using a TI calculator, the mode setting is right next to the second button. So you can hit mode, scroll down, and you can choose your options, either radians or degrees. It is important if you are using degrees that you are in degree mode, or that if you are using radians, you are in radian mode to get the correct form of the angle. And then to find the trig functions of your reciprocals, cosecant, secant, and cotangent, we need to use the reciprocal identity. So cosecant would be 1 divided by sine. Secant would be 1 divided by cosine, and cotangent would be 1 divided by 1 divided by tangent. So just a couple things to keep in mind as we're heading along here. However, for this and for today, we will not be needing to use a calculator unless you need help solving the Pythagorean theorem. So every time you are evaluating angles of trig functions, before you start, there are 3 things that you should write down. First thing, draw your special right triangles. This is really important because when we evaluate our trig functions, we are using those reference angles to figure out what our sine and cosine and secant and cotangent and all of our trig functions are. So my biggest tip to you is the second you get a worksheet that has to deal with evaluating trig functions, the second you get a quiz or a test that has to deal with it, draw your 2 special right triangles so that you can continue to reference those throughout the assignment or quiz or test. Second thing would be to draw the angle given. If the angle is not already drawn for you, draw it yourself so you know where you're talking about. You can figure out what the reference angle is. You can kind of identify where you're going with that trig function. And then finally, you want to label the quadrants with your positive trig functions. So that was the ASTC, or saying all students take calculus, so that you know for each quadrant what value should be negative and what value should be positive. All right, so we want to be able to figure out our trig identities if we are given a coordinate point. So we want to expand from the context of angles of a right triangle. We're going to consider a ray from the origin through a given point x comma y. And this point could really be anywhere. So we're just at this point trying to get a rough understanding of what our triangle should be, what our trig functions are going to be in terms of x and y. If our coordinate point is x and y, we see that we have this nice right triangle here. Our base is going to be x, so our run is going to be x. Our rise is going to be y. And our hypotenuse, in this case, we're going to label r. I mean, they have r as radius as well. We will always base these triangles with the angle stemming from the origin. So we can always go based off that origin. Now we want to figure out the 6 trig functions of this angle. First, we'll look at the sine. Sine is going to be our rise over hypotenuse, or opposite over hypotenuse. And so our rise over hypotenuse is going to be y over r. Cosine is the run over hypotenuse or adjacent over hypotenuse. So cosine is x over r. And finally, tangent is rise over run or opposite over adjacent, which is y over x. We can find the cosecant, secant, and cotangent by taking the reciprocals of these functions. So you guys can go ahead and do that on your worksheet. So now, if we actually look at a value, we're going to let 3, -4 be a point on the terminal side of angle theta in standard position. What that even means, we can look at this point 3, -4 right here on our graph. That is over 3 on the x-axis, down 4 on the y-axis. And this makes a nice right triangle with our angle stemming off of the origin. The terminal side just means our terminal line, creating our angle, is where we go from the origin to the point 3, -4. So that's what that means by let 3, -4 be a point on the terminal side of the angle. So that just means it's a point going through our terminal line. However, before we start trying to find the 6 trig functions for this, we need to figure out what our hypotenuse is. A lot of you guys will recognize this as a common 3, 4, 5 right triangle. However, if you did not know that, you could use Pythagorean theorem to solve for that hypotenuse. All right, so what I want you guys to do now is to pause this video, see if you can come up with these 6 trig functions for theta, the angle stemming off of our origin, and then resume the video and double check out your answers. All right, welcome back. So, my apologies for the bell in the background. A lot of you guys probably got this for your answers, which is perfectly fine. However, there is one minor thing in the steps that we wrote above that we need to kind of figure out. So we have our quadrants, 1, 2, 3, and 4. And within those quadrants, we have our ASTC. So all meaning all functions are positive in quadrant 1. S meaning only sine and cosecant are positive in quadrant 2. T for tangent and cotangent are positive in quadrant 3. And C for cosine and secant are positive in quadrant 4. This means... my apologies. This means that sine and cosecant should both be negative since we are in quadrant 4, and tangent and cotangent should be negative since we are dealing in quadrant 4. Sometimes, instead of labeling this a positive 3, positive 4, because we went down 4, I will just label that side of the triangle as a negative 4 so that my fractions are naturally negative for the sine, cosecant, tangent, and cotangent when I'm solving for those trig values. But just always, always, always double check that the correct trig functions are positive or negative dependent on the quadrant that you're in. All right, so now what I would like you guys to do is once again pause the video, and I want you guys to try problem number 4. So I want -5, -12 to be a point on your terminal side of theta, and I want you to sketch your right triangle that stems off this point and see if you can evaluate the 6 trig functions of theta. Once you are finished, come back to this video to double check your answers. All right, welcome back. So we should have graphed the following triangle. We can use Pythagorean theorem to find that the hypotenuse of our triangle is going to be 13. We're basing everything off of the angle stemming from the origin. And if you labeled your triangle with a -5 and a -12, naturally we would have seen those negatives come out in our ratios for sine, cosine, secant, and cosecant. However, if you label those positive, we can double check with our ASTC. Only tangent and cotangent is going to be positive in quadrant 3, so everything else needs to be negative. All right, this problem is very similar. However, we are given different information. So we're given that cosine theta equals negative 8/17 and sine theta is greater than 0. So this means our cosine value is negative, and if our sine of theta is greater than 0, then sine is positive. So we need to think of what quadrant is cosine negative, but sine is positive. And that's going to happen in quadrant 2. So we can go ahead and sketch our terminal side, and we know that our terminal side of our angle is going to end up in quadrant 2. We can then create a right triangle out of this by looking at this coordinate point up here. We know that cosine is adjacent over hypotenuse, or run over hypotenuse. So we can tell that our run is 8 and our hypotenuse is going to be 17. Since our cosine value was 8/17, it's negative because it's in quadrant 2. We can use the Pythagorean theorem to solve for the rise. So if you'd like to pause the video now, you may solve the Pythagorean theorem and then come back and double check. All right, so you should have found that our rise is going to be 15. So we can then try to find the values of the 5 trig functions of theta. Now that we have our triangle fully labeled, go ahead and pause this video and find, we're already given cosine, now find the 5 other trig functions of theta. All right, you can go ahead and double check your answers. Something of importance to note, because we're in quadrant 2, sine and cosecant are going to be positive values, whereas the other 4 will be our negative values. All right, now we have some special cases. So if the terminal side of theta lies on an axis, so an x or y axis, then theta is a quadrantal angle. So our 4 examples below are at 0 degrees, 90 degrees, 180 degrees, and 270 degrees. All right, you guys can pause the video to be able to draw your 4 examples of the angles, and then go ahead and continue on. Something important when we are going to be evaluating these, we're going to use the unit circle r equals 1 for these guys. So, for our trig functions of a quadrantal angle, we are going to first find theta at 180 degrees. So, a couple of things. In our problem number 2, we listed the 6 trig functions of an angle in terms of r, x, and y. We're going to be using those same exact things. But one of our hints was that our x value equal to negative r and our y value equals 0. So if we look at that unit circle at 180 degrees, we see that we have the coordinate point negative 1, 0. So our x value equaled negative 1, our y value equaled 0, and our r value at this point equaled positive 1, since our radius of a unit circle is 1. When we were finding sine, we noted earlier in problem 2 that sine was our y value divided by our r value. So in this case, we would have 0 divided by 1, which is just 0. Our cosine was our x value divided by our r value, which in this case is negative 1 divided by 1, which will equal negative 1. And our tangent, being rise over run, was our y value divided by our x value, which is 0 divided by negative 1, which will give us 0. For our cosecant, since it's a reciprocal, that would be our r value divided by our y value. So we would have 1 divided by 0. However, we cannot divide by 0, so this guy is actually undefined. Secant is going to be our r divided by our x. So we have 1 divided by negative 1, which will equal negative 1. And cotangent is going to be our x over y. In this case, that is negative 1 over 0, which once again we cannot divide by 0, so this value is undefined. All right. I now want you to try to evaluate the 6 trig functions of theta at 270 degrees. So if we look at our unit circle, we see that at 270 degrees, we have the coordinate point 0, -1. This means that our x value equals 0, our y value equals -1, and our r value, which is our radius of the unit circle, is a +1. So go ahead and pause the video. Using these 3 values, see if you can find these 6 trig functions of 270 degrees. Welcome back. All right, go ahead and double check your answers. Note that tangent and secant are undefined due to the fact that we cannot divide by 0. And we have sine and cosecant both as -1, cosine and cotangent at 0 for theta of 270 degrees. All right, that is it for the lesson today. Thank you for watching.